I'm Dil Tirimanna from FDN Group. We are partners of the URBCON project concerning the recyclable concrete. Wouter already discussed the material properties. And I also did hear a few questions coming up a little 10 minutes ago about the concrete. So maybe I can clarify more in my presentation. I will discuss in my presentation first the foundations in URBCON concrete. And secondly, I will go into methods of construction. It was only foundation blocks. So the whole building is a wooden, more or less a wooden structure. And only the foundation blocks are made out of URBCON concrete. So in first instance, you would say, yeah, okay, so what are your possibilities? But when you analyze this and concerning previous experiences, I will still try to explain possibilities which are still very innovative, which could be applied in this structure. Thirdly, the URBCON mix. I think that is, of course, mainly a part for Wouter to decide and to give. But as designers, you have certain tests that need to be done and certain material properties that are necessary to be able to design. Fourthly, I will go into the few tests that can be done. And in general, when we are speaking about a pilot project and a new concrete, there are certain things we need to know as designers, designing according to the European codes. And the fifth, I will give a few points on what would be nice to see as a demonstrator of URBCON in the Kamp C circular building. So those are actually, suggestions for the building team to consider in making the foundations. Yes, Marek. This is the foundation plan for the building, the part A and B. And you see that it's a 5 meter by 5 meter grid with foundation blocks. So in my presentation, I will focus on the design of these blocks, what the possibilities are for these blocks, and the reuse of the block or recyclability. So I did hear some questions previously about reinforcement, etc. So I will give an indication on what the consequences are of using reinforcement in design or not using reinforcement. So I think before I didn't comment, but I could go into those aspects at this moment. Yeah, so 5 meter block. And what you see immediately is that if you get large foundation blocks, which are traditionally like, I think now it's assumed 1.3 meters by 1.3 and 50 centimeter height. Those blocks are, of course, weighing about 2 tons each. So if you are going to reuse it for other applications, if you're using it for a building, it's okay. But using for other applications, the blocks are a bit too heavy. So there are possibilities to make them in parts and stack them on each other, or make them smaller. Next one, Marika. So we have focused together with Wouter, who is doing the mix design, on concrete C2025. The environment class for this building is EE2, but you also have to consider reuse of the blocks in, let's say, building a road, if the blocks are small enough, not too heavy, building a road or other modular temporary structures. Many times, those buildings are often placed on the foundation, on foundation blocks. So if you want to be able to transport them, reuse for other projects, the EE3 class with frost and chlorides is advisable. So further, you need a certain amount of covering for reinforcement if you're using reinforcement. And for the design of these blocks, the reference period will be about 80 years, according to the rules. And of course, this structure is not meant to last 80 to 100 years, but it's meant for between 10 to 30 years. So depending on that, you could also reduce covering and other loadings of the structure. Marek? So this is a typical foundation for a building. It is a foundation concrete block with a column placed on it. So yeah, this is of course the most traditional way of building a foundation. When you're in housing internationally at this moment, if you see especially chemical plants, refineries, all the drums and machines are always placed on foundation blocks. So there's a lot of experience everywhere with many companies in design of these blocks. So one thing you always see is that if you're not using reinforcement, the block becomes 2 or 3 times thicker. By placing a small net of reinforcement in the structure at the bottom for the tensional forces, the block size goes down a factor 2 to 3. So that's very interesting in this case. If you want foundation blocks which you want to reuse, which are easily liftable, blocks around 300-400 kilos, you need to add reinforcement nets in it. So it's not complicated, just a small net of reinforcement at the bottom. If you're not doing that, the blocks are large. So that is one aspect to consider here. Marika? Yes, so there are 3 methods of making these blocks. You could prefabricate them. In general, if you see internationally, the pedestal blocks, the foundation blocks, they are always poured on site because mainly they use as less reinforcement as possible, and then it becomes too heavy to transport. So making them on site is one of the main solutions for large, heavy blocks. But if you are going to explore circularity and reuse, then it's better to prefabricate them in small size and place them so that it's easily liftable. So I'm speaking of, so if you need a large concrete block, foundation block, which resists a lot of vertical force, then you could also stack them up together. You could put a piece of felt on top of one block and then place the next block and mount it up. The other point is, of course, reusing these blocks for maybe building, many times we use them for temporary roads, but then temporary roads, cycle paths, but then the block is about 10 to 15 centimeters thick, and the dimensions are mainly around 1 by 1 or 2 by 2. So when deciding on the size of the blocks, you should also consider reuse in other projects, and then you come up to these standard measurements. Yeah, and especially the block in that case, when reusing, is never thicker than about 20 centimeters. It's always below the 20. And that's mainly because a small crane on a truck, many contractors have these trucks, they come and pick it up and place them elsewhere. But the application, if you use such concrete blocks, is enormous when for recyclability, recycling or reusing in another project. And point 3, I will also show some examples where we have printed concrete, and printing such a block is also a possibility. At Kamp C, I have seen a printer. Also, I think University Ghent and many others have a printer. And I'll show some possibilities also because this is a simple block of concrete, but then the project becomes really innovative if you start printing them. And we have about 50 blocks to be done. So it can always be decided if a part of the block would be printed. Marika? Here you see a project we've done before a few years ago. The whole structure is made out of, modular elements. it's a bridge deck of about, I think, 26 meters, all elements. So the side railings, the deck, everything is modular. If you look well, you could see every 4 meters, there's a a connection. And these structures are made in concrete and can also be demounted. So that means they can be taken apart, the railing and the deck element. So they could be taken apart and reused in other constructions, other projects. Yeah, here you see the concept. You have railing and plate elements. So actually the same system applies if you are using foundation blocks, that you place the concrete elements together. In the case of the circular building, a Centrum building, you would not have even connections. The foundation blocks in layers could even fit together like Lego. You could make a little system where they click to each other. Next, Mike. Yeah, here you see the deck of that bridge which I just showed. Here they had to make the structure light, polystyrene core, so that the weight was much less. But it can be polystyrene, or it can be also be just air, and make elements. And it's mainly because also of transportability. And in bridge structures, of course, the weight has to be really considered. We normally want very light structures. But in the case of a foundation, you always want heavy structures. But if you are going to replace them after, let's say, 5 or 10 years, then it's good to think about a light structure. And when thinking about light structures, of course, you get other complications. So here you see a wall built out of concrete blocks. And it's like a Lego system that they are placed on top of each other, and that there's a certain connection in between with friction and a shear key like that they don't fall off. Next, Michael. Here you see it's very standard in many countries to use concrete plates for cycle paths, for events, parking places. So if you make the concrete blocks of the foundation in a certain dimension, they could always be reused. The life expectancy of such a plate is almost always around 80 to 100 years. So it could be reused. So not only recycling of URBCON concrete and making a new mixture, but also having durable elements which last a long time and which have more usage possibilities should also be considered here. The third option was to be explored was, of course, printing. Here we see with a printer that when you print concrete, in URBCON also we are exploring this possibility. When you print and you print it quite fast, you get like, here we have printed on the left, you see a picture, printed layers of about 1 centimeter thick and about 5 centimeters wide. When you overlap print layers, and later we've cut a section, you see that it is homogeneous. So it purely depends on the speed of printing. So now if you see, I will show a few examples hereafter of quite complicated structures which are printed. So in my opinion, even printing the blocks is really a feasible option. Here you see where we've gone from zero to printing a heavy traffic bridge. So it was about research for about 2 years. And the research phase has been finished with also testing of large span printed beams with heavy traffic loads. Here you see the setup of one bridge arch of 10 meters length, which is loaded with 200 or 20-ton vertical loads in the middle. So even with printing concrete, this is possible. So if even a large bridge beam is possible, then a foundation block should certainly be possible. Here you see us printing, and what we are doing is that the print concrete is quite good concrete, but to get a slender structure, we place reinforcement bars by hand between the layers. So nowadays you do have printers of concrete which blow a certain small steel wire, but that is not enough in bridge construction for taking up tensional forces. So here you see us printing and placing reinforcement layers between the concrete layers. And analysis of this kind of structure is very well possible once you know the material properties. You have nowadays 3D animation software where you could figure out all stresses in such a structure. So to choose the right URBCON mix, that is the part of the concrete technologist, as designers and contractors, what normally is needed is the fulfilling certain or getting certain material properties with which you can design. So here, this is a standard list of 12 tests normally done for pilot projects. And when you're designing the concrete, you really need the compressive strength, flexural strength, E modulus, the Young's modulus. Further, tensional strength, especially for these foundations, you need to know the tensional strength, because underneath there will always be tension. And in certain cases, if the concrete tension is exceeded, you need to put reinforcement there. Further, frost and thaw cycle is, I think, not the case. Yeah, frost is the case here, so that also needs to be tested. Chloride is not needed for the foundation blocks. For if you're applying the blocks later for a cycle path or a pedestrian path, then it should also be tested. Further, in general, the porosity, number 8, porosity says something about the quality of the concrete. You know, as designers, it's interesting. The density of the concrete is needed. And then, yeah, we normally also test carbonation depth, but probably not needed here. And the shrink and creep is more for slender structures, not for massive foundation structures. Number 12, the shear modulus is also important to know, as it's a shear force that will come on a foundation block. Here's the compression test. It's a very simple test done in the lab. I think Walter will have all the machines to do such tests. And also for a foundation block, this is a picture of a small test on scale factor 3 for the large bridge beam, which is printed, and you could easily do test. Here we are just loading it with some concrete plates to see what happens. So such tests could also be done at the university or on site, because the underground is also decisive in this case. So you could do a test on site and put loadings up to, I think, about 30 tons onto the plate to see what happens. So these testing could also be part of the program, and you could do these tests also in a very simple way. It need not be too complicated. So coming down to the last slide, it is there are 3 possibilities. So that is that for the foundation blocks, demountable, so reusable blocks. Then you should figure out what could be possible use. If you make the blocks small enough and in a certain standard dimension, they could be reused for many things, which is already being done in different countries. Further, printed foundation is really a good possibility as you're printing blocks. And the third is that, yeah, it's a demo site, so you could experiment with things and show other contractors and building groups what is possible, because normally there is no time and knowledge and finances in standard projects. So in this project, especially through URBCON, it is possible to make some tests to show others that they need not be too afraid to use this kind of technique. And the fourth point is that, it could also be a combination. We have about 50 foundation blocks which are needed. So that could be made a combination of different URBCON mixers and also different methods of production. Thank you, Marika.